Okay, so now we're going to look at points on a terminal arm of an angle. So we're going to draw our angle in standard position and then find the sine, cosine, and tangent values for that. And we're going to think about our cast rule for this as well. So let's start with our point 2, 5. So with this point, if I think about where 2, 5 is, if I made myself some coordinate axes, then it would look like this. So the point 2, 5, let's say, is up here somewhere. And then let me draw that terminal arm. So there's my terminal arm. And I've got my angle theta here. So 2, 5 were my coordinates. So if I think about a right triangle, then let me make this a bit smaller. Oops. And then we can move it in. Okay, so if I make my right triangle down here, I know that this distance is 2 because that matches my x coordinate. This distance is 5. I can use Pythagorean theorem. 25 plus 4 makes 29. So then over on my hypotenuse, I have a length of root 29. So I can use my ideas of SOHCAHTOA to find sine theta, cos theta, tan theta. So sine theta is going to be 5 over root 29. And here we don't actually rationalize the denominator because it's nice to see the opposite side in the hypotenuse. Cosine, 2 over root 29. And then tangent. I know tangent is always going to be sine over cosine, so the root 29's cancel, and I get 5 over 2. If I want to find theta, I can use inverse trig function for any of these, and I'm going to get the same value. So let's look at our calculator here. I'm going to slide us over just a bit. Okay, so if we do any one of these, we're going to get the same value. Oops. Go to, fill in the blank. All right. I could do cos inverse of 2 over root 29. Goodness. Let's try that again. Or I could do tan inverse of 5 over 2. And all of them give me the same angle. So in degrees, 68.2. Of course, I could also find it in radians, and it's going to be something that's less than pi over 2, so something less than 1.7 or so. So 68.2 degrees would be my theta value. If I think about this next picture, now I've moved my point to negative 2, 5. So if I draw this one, I do not know why sometimes the shift key works and sometimes it doesn't. There we go. Pretend like I made that straight. And negative 2, 5 will be somewhere up here. So negative 2, 5. Now my theta measure is here, but my reference angle is going to be the same with the x-axis. Note that my reference angle, because I still have my 2 and my 5, this value is going to be the same. So my reference angle is the positive 68.2, but my theta value, I could actually say right now that my theta value here, so we'll call this theta sub b, and this one was theta sub a. Theta sub b is going to be 180 minus the reference angle, theta sub a. So I'm going to get about 111.8 degrees. Generally with degrees, we give them to the nearest tenth. And now I could state all my sine, cosine, tan values. I still know that this is going to be root 29. Hypotenuse is always a length. It's always going to be positive. My sine value is going to be exactly the same. Opposite over hypotenuse. So sine theta b is still going to be 5 over root 29, but now the cosine value of this theta is going to be negative. So notice I'm now into my second quadrant. My cosine value, my x value is negative. Notice if we came up here and said cosine of that angle, and then I tried negative 2 divided by root 29, I get exactly the same ratio. My tan value, sine divided by cosine, negative 5/2. I'm going to leave you to try C and D on your own. I'm going to write up the solutions for you to look at, but I want you to think about your reference angle and what your value should be. For theta b, since we're in quadrant 2, we know it should be between 90 and 180, and sure enough it is.